the acid-catalyzed addition of an alcohol to an alkene. So we can see in the general reaction scheme we have here that our starting material is an alkene, and the product of this reaction is an ether. This reaction is very similar to the reaction of water with an acid catalyst, which gives an alcohol product. So if you put an acid into an alcohol solution, if you mix these together, you will end up with some of your protonated alcohol and the majority of the solvent still being the neutral alcohol. So let's take a look at this mechanism, and I will use methanol so that it's not just an R group. Okay, so if we have methanol with an acid catalyst, we're going to have some protonated methanol. So that's what I'm going to start with. This is an electrophile. The alkene is a nucleophile. So the alkene will attack that acidic hydrogen and break the bond between the oxygen and the hydrogen. So this will give a secondary carbocation. If it were possible for this carbocation to rearrange to be more stable, so a tertiary carbocation would be more stable, if that were possible, it would occur. All we have here, though, is a secondary carbon and 2 primary carbons, so that won't happen. So that means the next thing that's going to happen is this carbocation will react with a nucleophile. So if we were working with a solution of acid and methanol, we have protonated methanol, and then we have a lot of just the alcohol, in this case, methanol as well. Just like water, alcohols can act as an acid here if it's protonated, and here it's going to act as a nucleophile in its neutral form. So we have those. Lone pair of electrons on the oxygen will form a bond with that positively charged carbon atom, which will give us this structure. So there's our new oxygen-carbon bond. This oxygen has a bond to hydrogen, and it also has a bond to that methyl group. So this right now looks like a protonated ether, so very close to that final structure of an ether. To get rid of this positive charge, we need to deprotonate. We need an acidic hydrogen that we can remove, and we have one here. Methanol, like water, can act as a nucleophile. It could also act as a base. So if I draw another methanol molecule, remember this is the solvent, we have a lot of it, this can remove that acidic proton, and we end up with the ether product. So when you're doing this reaction, whatever the R group is of your alcohol is what is going to be on your ether. So if you start with methanol, you're going to get a methyl ether.